Class, we're going to continue lesson 13.3, special right triangles. So this lesson, and we have one more lesson before we're done with credit 5. In this lesson, the goal is how to solve a right triangle problem using trigonometric ratios and the Pythagorean theorem. Before we actually get into this, let's kind of do a quick review of what is a right triangle, how do we use the Pythagorean theorem, and then we could talk about the special right triangles. So let me switch this to project. Okay, so let's talk about what a right triangle is. So a right triangle is a triangle where one angle is 90 degrees. In this triangle, we have three sides. The sides that make up the right triangle, or the sides that make up the 90-degree angle, are called the legs. So this is a leg, this is a leg, and this is called the hypotenuse. Earlier in this credit, we talked about the Pythagorean theorem, which is a theorem to find one side of a right triangle given two other sides. So let me draw a formula. So again, we have a right triangle. Let's call this side A, this side B, and this side C. And the Pythagorean theorem was a squared plus b squared is equal to c squared. Okay, so let me erase this and we're going to try a problem together using the Pythagorean theorem. And then after we do the Pythagorean theorem, we're going to go into special right triangles. So if I have a right triangle and this side is, let's say, 5, this side is 6, and I want to find out what this side is. I could use the formula, so a squared plus b squared equals c squared, and I would have 5 squared plus 6 squared is equal to x squared. 5 squared is 25, 6 squared is 36, and that's equal to x squared. 25 plus 36 is 61. So I get 61 equals x squared, and then to solve this, I will take the square root of both sides. So my answer, x equals the square root of 61, which is a number. If I use a calculator and type that in, the square root of 61 is 7.8. So this is equal to 7.8, which means this side is 7.8. So again, this is just review on the Pythagorean theorem. Let me switch back to the two theorems that we're going to be learning in this lesson. So let me go back here. So the first theorem that we're going to be talking about, let's scroll down here, is called the 45-45-90 right triangle theorem. The reason why it's called 45-45-90 is because the three angles are 45, 45, and 90 degrees. Notice that in this formula, they give you variables for the side lengths. So the legs of the right triangle are x, and the hypotenuse is x square root 2. Now we're going to be doing some examples that kind of cover how to use this theorem in a little bit. But let's look at the second one. The second theorem we're going to be talking about is a 30, 60, 90 right triangle. Now with the 30, 60, 90, the side that is opposite the 30-degree angle is the shorted side. The side that's opposite the 60-degree angle is the medium side. And then this is the hypotenuse. So the short side, or the short leg, is x. The long leg is x square root 3. And then the hypotenuse is 2x. Okay, so let's start with okay, so in this example, I'm going to call it example 1. We're going to be given a leg. So I'm just going to write given a leg using the 45, 45, 90 theorem. So, and then also let me on the side write the theorem on the side. So this is 45, 45, 90. This is x, x, and this is x square root 2. So my problem is this right here. So you have 45, 45, 90 right triangle. And let's say that they give us this side, or this leg. The question is, what is this leg going to be? And what is this hypotenuse going to be? Now, looking at the formula, comparing the formula to the problem that I have, I notice that this side is x and this side is 7. So what we could easily do is solve for x by setting x equal to 7. Once we know x equals 7, I'm able to use this formula and plug in 7 wherever there's an x. So since this side is also x, this side would be 7. And since this side is x square root 2, this side would be 7 square root 2. So now we have all three sides of a right triangle just by knowing one side, knowing that this is a 45, 45, 90 right triangle. So let me erase this and let's do another example. But in the second example, I'm just going to give you the hypotenuse. So what if we're given this side and we want to find out these two sides? So let me erase this. Okay, so example 2. Given the hypotenuse. So again, let me write the formula. So again, 45, 45, 90. This side is x, this side is x, and this side is x square root 2. So, and then in my problem that I have, I'm going to draw a right triangle. Again, labeling my angles, 45, 45, 90. And now the hypotenuse is 5. And I want to find out these sides. Now, because my hypotenuse is 5, and in the formula my hypotenuse is x square root 2, similar to the last problem, I could set this length equal to this length. So I could create an equation, x square root 2 is equal to 5. And we could actually solve for x by removing the square root 2 or moving the square root 2 to the other side of the equation. Square root 2 is connected to x by multiplication, so to move it we have to use division. I have to divide square root 2 to both sides. Square root 2 divided by square root 2 become 1, and I'm left with x equals 5 over the square root 2. Now in math, we don't want to have a square root in the denominator. So what we do is something called rationalize the denominator. And all that means is that we multiply the denominator by itself. So if the denominator is square root 2, I'm going to multiply square root 2. Now because I multiply the denominator by square root 2, I'm also going to multiply the numerator by square root 2. Whenever we multiply a square root by itself, it just becomes a number inside the square root. So my answer would be x equals 5 times square root 2 divided by 2. So this 5 square root 2 divided by 2 is in its simplest form, and that is what x equals. So these sides right here, this is 5 square root 2 divided by 2, and this is 5 square root 2 divided by 2. And that is how we solve this given the hypotenuse. So let me go back to the packet. And what I want us to do is look at this problem or this example. In this example, we're going to be using the 45-45-90 theorem. And what is given is the hypotenuse. So you see your equation in the right, or in the left, and you see your problem in the right. We could say x square root 2 is equal to 10. Because we have this side is equal to this side. And we have to divide both sides by square root 2. So we're left with x equals 10 square root 2. And this is again where we have to rationalize the denominator by multiplying by square root 2 over square root 2, which would give me 10 square root 2 divided by 2. Notice that the 10 and 2 are outside of a square root, and I can actually divide 10 divided by 2, which is 5. So I get 5 square root 2. And that is what x equals. X equals 5 square root 2. Now, for question 1, they wanted us to find the lengths of CA. So CA is 5 square root 2, and then BC is also 5 square root 2, because in this 45-45-90 right triangle theorem, both legs are x. Okay, so now I want to talk about the next theorem, 30-60-90 right triangle. So this is the formula again, and we're going to be using the formula to help us solve a problem. So let me switch this to the So first let me write our equation. So a 30, 60, 90. So I have a right angle here. This is 60 degrees and this is 30 degrees. The short leg is x, the long leg is x square root 3, and the hypotenuse is 2x. And the first example is going to be given the short leg. So if I have a right triangle, so again this is 60, 90, and 30, and I know the short leg is 4. How do I find the long leg and how do I find the hypotenuse? So because the short leg is 4 in this triangle and the short leg is x in the formula, I could say x equals 4. Knowing what x is, I could find the other two sides by substituting what x is. So if I plug in 4 here, I would get 4 square root 3. And if I plug in 4 right here, I would get 2 times 4, which is 8. So I found all my sides. 8 is the hypotenuse, 4 square root 3 is the long leg, and my short leg is 4. Okay, let me erase this. And now we're going to be doing an example where I'm given the hypotenuse. So I have a right triangle. This is 60, this is 30, and now the hypotenuse is 10. So what I do is I set this hypotenuse equal to this hypotenuse and solve for x. So I would do 2x equals 10, divide both sides by 2, and x is equal to 5. Now that I know that x is 5, I know that this short leg is 5, and this long leg is 5 square root 3. And last example, so the last example is given the long leg. So I have a right triangle. This is 60, this is 90, and this is 30. Now, if my long leg is 9, and I want to find my short leg and my hypotenuse, the first thing I would need to do is set this long leg equal to this long leg. So I would have x square root 3 equals 9, and you would want to solve for x. Similar to the 45-45-90 theorem, to move a square root 3 to the other side, you have to divide both sides by square root 3. Doing that, I get 9 over the square root of 3. And again, we have to rationalize our denominator by multiplying the top and bottom by square root 3 over square root 3, which gives us 9 square root 3. Now, square root 3 times square root 3 is 3. 9 and 3 can reduce, so 9 divided by 3 becomes 3 square root 3. So if x is 3 square root 3, so I know my short leg is going to be 3 square root 3. My hypotenuse is 2 times x. So 2 times 3 square root 3 becomes 6 square root 3. So now we have all 3 sides of our right triangle. Started with the long leg, we